Let's look at another example of a complete test here. Last year, CO2 emissions for a passenger car was 96.96 grams per kilometer, and the car manufacturer randomly selects and tests 10 new vehicles. That's going to be our sample size. With the results below, so these are the grams per kilometer of CO2 emissions. Can the car manufacturer conclude that the mean CO2 emissions for all vehicles this type differ from last year? So the mean differs. That's what we want to show. Alpha is 0.01 significance. So here they give us actual data instead of summary statistics, so we'll have to put that into the calculator and do one variable stats to start. So we want to go to Stat, Edit, and clear out any lists if you've got anything in there. So arrow up, highlight the list name, and then clear Enter. And now we want 0.93, 0.91, 0.94, 0.98, 1.01, 0.95, 0.92, and then we had 91, 98, 96. So 0.91, 0.98, and 0.96. So there's our data. Now we'll go to Stat, Calc, and then one variable stats. We are in list 1, that's what we want. Calculate. So our X bar 0.949. And then we will have a sample standard deviation of those 10, which is right here, 0.03348. Let's take out several decimal places here because it's so small. So null and alternative. So we're trying to see if it differs from last year. Last year was 0.96. So we are dealing with means. So our alternative, what we're trying to establish is mu different than, not equal to 0.96. If that's not the case, then the mean will equal 0.96. Determine the distribution. This is mean. And we are given S here instead of sigma, so this is going to be T distribution again. That'll happen most of the time with means. You're going to use T, and then Z for proportion. Compute our test statistic, so our X bar, that is the 949, minus our hypothesized is the 0.96, divided by S is 0.03348, divide by square root of our sample size, and sample size was n equals 10 right here. Let's put that into the calculator. So alpha y equal enter, and then up top we've got 949 minus 96. And then down on the bottom, 0.03348. So 0.03348 divided by square root 10. So negative 1.04 to 2 decimal places. So now we'll sketch and determine P. So negative 1, here's negative 1, negative 2, negative 3, negative 1.04 about right here. So there's our test statistic. And then the p-value is the area past our test statistic. Now, this is an equal, not equal, so we also have to mark on the right-hand side positive 1.04. And then the other half of the p-value comes from that. So each half is p over 2. So p over 2, half of the p-value is going to be either of these areas. Let's do this one. So that'll be TCDF The lower bound is 1.04. The upper bound all the way to the right, infinity, we use 10,000. And then our degrees of freedom, n is 10. 10 minus 1 is 9. So enter that into the calculator. So second variables, number 6. And let's see, we are going 1.04 to 10,000, degrees of freedom 9. 0.1627. And then the p-value is, since it's a two-tailed test, is going to equal 2 times that 0.1627. So go back to the calculator, times 2. So 32547, 3255. And now we can make our decision. So our P is 0.3255. We compare that to our alpha here, which is 0.01. And it's definitely greater than 0.01. So P greater than, we fail to reject. So do not reject. H0. So in other words, we accept H0 as being true, and the way you interpret that is you say that there is not sufficient evidence to conclude that the mean changed. So to conclude HA, to conclude mean not equal to, and ours was 0.96. So in other words, the mean did not change. Not enough evidence here. You can also check this one on the calculator. So we've got that data entered in, so we're going to go to stat, tests, and number 2, t-tests, except this time we're going to highlight data. And then we have to put in our hypothesized value, 0.96. Our list is in list 1 is our data. And then frequencies are all 1, and then we're going to do a not equal test, so we highlight not equal. And then let's go ahead and do the draw on this one. So you can see there's our p-value is shaded, just like we had here. 1.0389, so 1.04, and then p 0.326, and we got 3255. So again, we're off by a little bit in the 4th decimal place, and that's because of rounding up here. Actually rounding here, rounding in the t-value. So, but it is confirming what we did by hand, that we do not reject.